Applications of integration, page 7. The velocity of a moving object is given by this equation. If s equals 16 when t equals 0, find the displacement function. Okay, so why are they giving us this information? This is a way for us to figure out the integration constant. Because, remember, to find the displacement function, what we do is we take the integral of the velocity function. So, let's do that. We're going to take the integral of 32 plus 4t. We're going to ignore for now this information. We're going to use that in a little bit. So we're going to integrate this, do an indefinite integral. And the integral of 32 is 32t. The integral of 4t is 4t squared. And then we can evaluate that. This is not a definite integral, it's an indefinite integral, so we'd put plus c at the end. And then we know that when t equals 0, that s equals 16. So remember that this is s. So s of 0 is equal to 32 times 0 plus 4 times 0 squared plus c, which is just equal to c, right? And s of 0, remember, is equal to 16. So we just discovered that c equals 16. Now let's rewrite it with c equals 16. 32t plus 4t squared plus 16. That is s of t. Okay. Explain why the displacement of the object and its total distance traveled in the interval 0 to t1 can be represented by the definite integral 0 to t1 32 plus 4t. Remember that complex procedure we had to discover the total distance traveled. And the total distance traveled is complicated because sometimes an object changes direction of velocity. Every time the object changes direction of velocity, you have to divide the region to integrate, because suddenly part of the integral is going to be below the x-axis, part of it's going to be above. You're going to have a positive section which cancels with the negative section. It's going to screw up your total distance traveled because you need to have the positive sections, the areas calculated separately from the negative areas so that you could take the absolute value of everything and add them up. Now in this case, the reason why you could use just a straight definite integral without dividing into sections is because the velocity change for this function does not occur in the positive axis. Like look when it changes direction. It changes direction when t equals -8, right? So in the interval 0 to t1, no direction change. Which means that the integral, or the definite integral is in one piece, right? It's not divided into sections. Show that the object is traveling with constant acceleration. Okay, remember that from velocity to find displacement, you take the integral. Now, if you have the velocity and you want to find the acceleration, remember that you find the derivative. So you could actually find the derivative of 32 plus 4t. That would give us derivative of 32 is 0. Derivative of 4t is 4. So it would be equal to, the acceleration would be equal to just 4. So we just showed this constant acceleration. Okay, number 5. A particle moves along the x-axis with the velocity function x dash equals 16t minus 4t cubed units per second. Find the total distance traveled in the time interval blah 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 and blah blah blah. So let's see. This is the velocity function. We don't know yet if the total distance traveled is going to be found in the velocity function cut up into sections and found and the area found separately. But in order to do that, we need to figure out, are there direction changes here? To figure out if there's direction changes, we could find the zeros, the direction changes of this function. So we could say, we could factor out a t of 16 minus 4t squared. Actually, we could factor out a 4, and then we'll have 4t minus t squared, right? Oops. Not 4t minus t squared, it's 4 minus t squared. Okay. And so the roots here are going to be t equals 0 and t equals plus or minus 2. Okay? So the direction changes are at t equals 0, t equals negative 2, and t equals plus 2. Okay. And, oh, look at that. They're asking for the total distance traveled between 0 and 3. But we already know that there is a direction change at t equals 2. Oh, man. So, we know that we cannot find this distance without cutting it up into pieces. All right? So, and let's just figure out the sign changes here. So, like, for example, let's put in s equals 1, or v equals 1, or t equals 1, I'm sorry. When you put t equals 1, we're going to get 16 minus 4, which is 12, so it's positive. When v equals 3, or a really big number, we're going to get a negative number. Okay? So in the area of interest, which is from 0 and above, we can see that we have positive velocity here and negative velocity here. Okay. Let's find the integral of the velocity function. That will give us the displacement function, which we need to know to find the total distance traveled. So, let's see. The integral of 16t minus 4t cubed is equal to 16t squared over 2 minus 4t to the 4th divided by 4, which is equal to 8t squared minus t to the 4th, which is equal to t squared times 8 minus t squared. Okay, so that's the displacement function. Now we can find the total distance traveled from 0 to 3 using the definite integral from t equals 0 to t equals 3, but we do need to divide it up into two sections. We need to divide it up into 0 to 2 when the velocity is positive, and 2 and above, which is when the velocity is negative. So we're going to do 0 to 2, and then we're going to have the whatever it is, and then we're going to have minus from 2 to 3, because the 2 to the 3 section is a negative area, so we want to take the negative of that. And then we already know what the integral is. It's that. So first we're going to evaluate this integral, t squared 8 minus t squared, and oops, I'm going to leave it in the multiplied out form. I don't see any reason to factor it for now. So I'm just going to leave 8t squared minus t to the 4th, and I'm going to integrate it, or I'm going to evaluate it from 2 to 0, and then I'm going to do the same from 2 to 3, but I'm going to subtract it. So here, I'm going to write it down here. So 8t squared, so with 2 substituted in, would be 32, right? And t to the 4th with 2 substituted in would be 16. And if you put 0 in for either one of these, you're just going to get 0. And then let's do the next part. The next part, we're going to put 3 in for 8t squared. That would be 48. Actually, it wouldn't be 48, it would be 72, right? Because it would be 9 times 8, 72. And then we would do, let's see, a minus negative t to the 4th. T to the 4th with 3 would be 81. Okay, so let's see what we got here. We got positive 16 plus 9. Which would be 9 plus 16 is 25. Okay, so the answer to part A would be 25. The answer to part B, which would be the same integral from 1 through 3, let's make this smaller so I can still fit in the other calculation here. Okay, so now we're going to be doing the same integral from 1 through 3. And we know that the 0 point for velocity is 2. So we have to divide this integral into the integral from 1 through 2 to plus the integral from 2 to 3. Because the 1 through 2 integral is positive, the 2 through 3 integral is negative. So, oops, and we need to put a negative here too. To negative the negative and make it positive because we want the absolute value of everything. So when we do this, we are going to have the exact same inside as we did before, 8t squared minus t to the 4th, evaluated from 2 to 1, minus 8t squared minus t to the 4th, evaluated from 3 to 2. Okay, so if you put 2 in for that, you get 32. And then if you put 2 in for this, you get 16. And then if you put 1 in for that, you get 8. And if you put 1 in for this, you get minus 1. What about if you put 3 in for that? You get 72. And if you put 3 in that, you get 81. And then you have a minus negative, which would be positive. You put 2 in for that, you get 32 and 16. Okay, so this gives you 16. This gives you 16. This gives you 7. This gives you positive 9. So you got 16 minus 7, which is 9, minus 9, which is 0, plus 16, which is 16. Okay, so part C, or part B, the answer is 16. Number 7. The velocity of a particle traveling a straight line is given by this. State the initial velocity of the particle. Okay, that's easy. Remember the initial velocity, you always just put in 0. So, you go to 15 minus, ooh, look at that. we're going to have 50 minus 10 e to the 0. Remember, e to the 0 is not 0, it's 1. So 50 minus 10 is 40. So the initial velocity is 40. Find the velocity of the particle after 3 seconds. Okay, so now we just do 50 minus 10 e, and the 0.5 times 3 would be 1.5, so it would be negative 1.5. Okay, and obviously we're going to have to use the calculator here if we want an exact answer. Why don't we could just put this function in here, and then we could get all the possible values there are. 50 minus 10 e to the negative 0.5 t. And so let's look at the table. And there we found the initial velocity is 40. And the velocity after 3 seconds would be 47.769. 47.769. 47.77, right? How long will it take for the particle's velocity to increase to 45? Well, since while we're using the calculator anyway, why don't we look for, when does it turn to 45? Ooh, that's weird. Okay, it's already gotten up to 50. It started out at 40, so actually it happens very early. It happens between 1 and 2 here. Let me show you the elegant way of doing this. Go to y equals. You put y equals 45, which is the desired velocity, right? Now you've made two graph functions here, and one of them is on the screen, the other one's off the screen. To get both of them on the screen, we need to do let's do a window, and make sure that the y max is going to be like at least 60 or so, because remember our horizontal line is at let's see, 45. Now let's graph it. Okay, so there is our velocity function, and there is our velocity equals 45 line. And now we could do it intersect, second calc intersect, which is option 5. And we'll say first curve is this function, 50 minus 10, blah, blah, blah. Yes, it is. Second curve is 45. Yes, it is. And then it says, what's your guess? It doesn't really matter what your guess is. There's only one intersection, so you don't have to be careful about where the cursor is. So you just hit enter. And the intersection is going to be 1.39, comma 45. Hey, that is how long it takes to get to 45 meters per second. T equals 1.39. Discuss v of t as t approaches infinity. Okay, so as t approaches infinity, you can see that the velocity actually approaches a certain number. If you look at the table, you can soon see that the number that it approaches is 50, right? In fact, it gets so close to 50, it turns into 50 on the calculator. Show that the particle's acceleration is always positive. Okay, well, I think it's easier to do this with the derivative. So you take the acceleration of the velocity function, you're going to get derivative of 50 is 0. The derivative of negative 10 blah, blah, blah is negative 10 times e to the negative 0.5t times the chain rule, which is negative 0.5, which is equal to positive 5 e to the negative 0.5t. And so you can see that whatever number you put in for t, it's going to be a positive number, and then this number, negative 0.5t, is going to be a big negative number. And if this is a big negative number, then that means e to the big negative number is actually like a really small number. And actually, we don't need to analyze it that much because, like, it's an exponential. And it's a positive exponential. So like, even if you put negative numbers in here, you're always going to get a positive number, right? So the acceleration is always going to be positive because there's an exponential there. Exponentials are always positive if they don't have a negative sign in front of it. Draw a graph of v of t against t. Okay. So we could just like copy what's kind of in the calculator. There's an asymptote at 50, and let's look at the graph again. And it goes kind of like that. Okay. This line here, remember, is 45, and so the asymptote is 50. So that was F. And maybe we could even put in this point here. It's 40, right? The velocity at t equals 0 is 40. Okay, so that's F. G, find the total distance traveled by the particle in the first 3 seconds of motion. Okay, it's always going in a positive velocity in the first 3 seconds of motion. So we could just do a straight integral of 50 minus 10 e to the negative 0.5 t from 0 to 3. And that's going to give me 50 t minus okay, right? This would be the integral of that. So actually we could simplify this a little bit. There's two negatives here. We could make that positive. 10 divided by 0.5 is actually going to be 20. So, and then we can evaluate this. First we're going to put 3 in here. So we'll have 50 times 3, which is 150, plus 20 e to the negative 1.5, right? If you put 3 in for t. And then you subtract 50t with 0 plugged in, which would be 0, and then you would subtract 20 e to the 0, which is just minus 20. So the answer would be 130 plus 20 e to the negative 1.5. So we could find that with the calculator. We could just put 20 times e to the negative 1.5 plus 130, which would be 134.46. Okay, that's it.